Simplify the following square root. So the square root of 72, I want to simplify this. So recall that when you simplify a square root, it's almost like the same idea as when you reduce a fraction, where they're still going to have the same value, except that they just look differently. Okay, so we have to recall the list of perfect squares, and I want to see which one of these numbers divides into 72. So which one of these is a factor of 72? So I'm going to go through my list. So I'll do 72, I'll divide it by 4, and I can see 18 is an integer, so I know 4 is a factor of 72, and it goes into it 18 times. So I can rewrite 72 as a product of 4 and 18, where 4 is a perfect square. Once I have a product inside of the radical, I can split that up. So we have square root of 4 times square root of 18. That's one of the properties of square roots. So these are still have the same value. And I can see here the square root of 4, I can actually do that because I got 4 by doing 2 times 2. That's the result of multiplying 2 with itself. And that's what a square root is asking you. What number times itself is 4? So that's how you can interpret this square root. And this number would be 2. So 2 times 2 gives me 4. And then I'm going to bring back down what's left, so it's square root of 18. And then I have to ask myself again, is there any perfect squares that goes into 18? So I would go through my list again, and I'll say, okay, let me do 18. And I actually recognize that 18 is divisible by 9, because 18 divided by 9 is 2. So I can rewrite this as 2 times the square root of 9 times 2. So notice it's 2 times the square root of 18. So the only difference between this step and this step is that I rewrote 18 as a product of 9 times 2. So we're not going to drop the 2. We need that. That's important. And now I just repeat what I did earlier. So 2 times, I have a product within the radical, so I can split that up as 9 times square root of 2. And now I have 2 times, well, this is saying what is the square root of 9? In other words, what number times itself is 9? Well, that number would be 3 times the square root of 2. And then the only thing left to multiply is 2 times 3. So I get 6 times the square root of 2. And then I ask myself again, do any of these perfect squares go into 2? And I can see that none of these are factors of 2. And therefore, I simplified my square root. One thing to look back at is if you notice you have to repeat this process more than once, that means you did not find the biggest perfect square. And one way to check from this point, once you get your final result, if you wanted to know what was the biggest perfect square, you can see there's two ways to do it. 6 times the square root is the answer I got in simplified form. If I were to think about the previous step, the step prior to that, I would have had square root of 2 and the square root of some number. So the square root of which number is 6? Well, if I were to go through this list, I know that 36 is 6 times 6. So this would have been 36. And if I were to go back one more step, square root of 36 times 2, and I can see working backwards, it gives me back to my original square root of 72. So if you have to repeat more than once when you have to simplify, that means you didn't pick the biggest perfect square. And if you follow back like I did here, you can find out what that biggest perfect square is. So pretty much you have to go just one step prior to your final solution, and you would have seen that the fastest way to solve this was if you would have divided by 36. So to make the process a little bit easier in the beginning is when you're trying to simplify is look at your list of perfect squares and see if you can find the biggest perfect square that is a factor of the radicand that you're working with. Once you find the biggest one, then you won't have to repeat this process.